Good morning, afternoon, and evening to everyone. Thank you for joining us from wherever you are today. It is March 6, 2025, and we want to welcome you to our 7th webinar in this series focused on history of people, forests, and forestry. This series is co-hosted by the Forest School at the Yale School of the Environment and the Forest History Society. My name is Tanya Muntz, and I am the president and CEO of the Forest History Society based in Durham, North Carolina, in the United States. I'm one of your hosts of this series and will be introducing today's webinar. But first, I'd like to do a quick introduction of our hosts. First is Professor Mark Ashton. Mark is the Morris K. Jessup Professor of Silviculture and Forest Ecology and the director of the Yale Forest. You can see him here on the slide in the middle. On the right is Gary Dunning, and he is the executive director of the Forest School and the Forest Dialogue, both based at the Yale School of the Environment in New Haven, Connecticut in the US. And Gary and I are going to be trading off facilitation duties for this series. As you know, this Yale Forest Forum webinar series explores the history of people, forests, and forestry. We're now over halfway done through the series, and as you can see on this next slide, we still have a fantastic slate of speakers and themes that we've lined up for you over the coming weeks. Please note that there have been a few recent changes, in particular for March 20th and April 3rd. On this slide, and also on the Yale Forest Forum website, you can see the final schedule. And just a quick note, if you have been receiving some emails, some scheduling cancellations, don't worry, those are only for sessions that have been canceled. The series is proceeding as scheduled, and your registration is good for all the other talks as they're outlined on this slide. That said, I do want to note that next week we're off for the Yale University spring break, and then we're back on March 20th to resume the series. And I'll talk after the session a bit more today about that March 20th slot. A quick reminder on the logistics of this series. The series convenes on Thursdays from 12 to 1 p.m. Eastern Time in the US, and we are going to be holding the series through April 3rd, as you can see. Each webinar runs roughly 30 minutes with audience Q&A to follow. If you have a question and you'd like to submit it, please enter your question into the Zoom's Q&A function. Each session in the series will also be recorded and available on Yale Forest Forum's website shortly after the session. And if you have any questions or want to get in touch with us, please email us at yff@yale.edu. And now it is my total delight to introduce today's speaker, Larry Barham. Larry is a professor of African archaeology at the University of Liverpool in the UK, and he's conducted research on technological change in the African, quote, Stone Age in sub-Saharan Africa, primarily in Zambia, but also in Ghana. The African archaeological record gives us a unique perspective with which to view human responses to long-term processes of environmental change. And the period from 500,000 to 300,000 years ago is of particular interest to Barham as it predates the evolution of our species, but sees the development of a conceptually new approach to making tools. In particular, he's shown how the combining of two or more parts to work together as a whole tool marks a fundamental change in human technology and one which underpins all modern technologies. Today, Larry's talk is titled The Deep Prehistory of Human Use of Tropical Woodlands in South Central Africa. And with that, I'm going to welcome Larry and hand it over to him. Larry?
Thank you, Tanya. And thank you to the organizers of this forum. There we are. Let me share my screen, but before I do so, I just want to say, as an archaeologist, as you've heard, I have an interest in technology. And it was because of the recent discovery of waterlogged wood dating 500,000 years ago that I stepped back and thought more deeply about the surroundings in which the prehistoric inhabitants lived. I hadn't really given the forest much thought because most of our time than thinking about stone tools. I just say again that as an archaeologist, I've only recently come to appreciate the importance of woodlands, because most of my time has been focused on stone tools. And it's a wonderful experience to suddenly realize that Stone Age is more likely to be a wood age. What I want to tell you then is about the miombo woodlands of South Central Africa. So this is the overview of the talk. We'll look at the ecology of miombo woodlands, its biogeography for the plant and animals that are available. And I'm going to think about them and ask you to think about them through the same sort of eyes I have here. And that's thinking of hunter-gatherers living in these woodlands going back 500,000 years, but also more recently farming communities, and how they've adapted and what resources these particular woodlands offer. We're going to look then at the paleoecology of the miombo woodlands. They're quite old, and we assume, I think, the human use of them is also equally old. And then I'll drop into the archaeological record of two particular sites that will give us a sense of how we as archaeologists work and reconstruct the early human settlement in the miombo woodlands, and I'll particularly introduce you to the unexpected discovery of the earliest evidence of a wooden structure in the world. And then we'll close quickly with current challenges to the miombo. Face the challenges from deforestation on a large scale and climate change. Okay, let's introduce then the ecology. As you can see in the image here, there's a long expanse of unbroken woodland. And this is, in fact, the largest dry forest ecosystem. It's woodland savanna. It's the largest in southern Africa and perhaps in the world. And anybody who's familiar with the Cerrado woodlands of South America, Brazil, it's on that same sort of vast scale. The talk we had last week from Annabelle, working in the Maya woodlands, she introduced a huge amount of biodiversity. The miombo woodlands, much less so. In fact, the range of tree species that typify this woodland is quite low. It's typified by broad-leaf leguminous trees, particularly the genera Brachystegia, Julbernardia, and Isoberlinia. There are other species, about 8,500 plant species, but in terms of tree diversity, relatively small range here. As the picture shows here, this is an open canopy woodland. It has a developed grass layer, which is important in terms of the biogeography and basically important in terms of the large mammal species available. It has a distinctive feature, miombo, in terms of its structuring, and that feature is fire. It's a fire-adapted landscape. Fire is natural in this landscape from the long dry season, but also fire has been enhanced by human intervention. So briefly, contemporary ecology. So as well as what I've just said about the forest system, I just want to show you the legumes and how they hold their seeds. So these are the big pods of the species such as Brachystegia. And they're very woody. We think of them as large sort of peas in a pod. As you walk through the woodlands in the end of the dry winter months, and it's just warming up, those pods start, you'll hear them in the forest. They will crack. It's almost like a rifle shot, just pow, pow, pow. And the pods are twisting and opening, and they are dispersing their seed. It's very distinctive. The pods are edible for animals, not for humans, but they have many uses. Right. The drivers of miombo, the sort of the factors that lead to its formation and distribution, really quite simple. We can show in this diagram here, this is the intertropical convergence zone, and this was mentioned last week in the context of the Maya forest. And this sort of global band of rain, which is permanent, but just shifts with the seasons. At the moment, if you look at the blue band, this is, let me just put up the laser, the blue band is right over Zambia and this part of South Central Africa now. It's the wet season. and it's their summer month. And it is a very distinctive part of the miombo woodland, is that warm summer rain. The rainfall also characterizes two forms of miombo. This is sort of a well-known separation, goes back into the 1970s, and separation between wet miombo with an annual rainfall of over 1,000 millimeters, and a dry miombo under 1,000 millimeters. And I just want to draw attention to the dry miombo, because there is a lower threshold of 600 millimeters, beyond which the miombo will not thrive. And I'll be mentioning this again in terms of the paleoecology, and also future climate change and what impact it may have on miombo woodland. Let's just look then at the distribution of wet and dry miombo, which then gives you a sense of the geological diversity, not the diversity, but the extent of this landscape. In dark green here, we have wet miombo from Angola across to Zambia, and then into southern Tanzania and into parts of Mozambique. Dry miombo is this olive green here, and then superimposed, you can see the location of Zambia. Zambia is the center of the greatest diversity of the species of Brachystegia. So, even though the diversity of trees in miombo is relatively low, Zambia has the highest number. The soils across this region are developed on what's known as the African Shield. These are old, ancient granites and quartzites, and they produce a nutrient-poor, acidic soil. As a result, well, particularly in the last couple thousand years, with the arrival of farming communities, there is what we assume to have been part of that initial adaptation, a form of shifting cultivation, swidden agriculture, or what was called last week milpa. And in the context of Zambia and across this region, there's a name, Chitamine. It's I don't think the term slash and burn is appropriate here, because the slashing is actually quite limited. It's cutting down branches, but also cutting down trees, but not right to the ground, leaving stumps for regeneration of the woodland. And traditional agricultural system here would be basically farming, cultivating in this forest patch, a clear patch, for a few years until the soil nutrient value dropped. Community would then leave and leave for some years, allowing the woodland to regenerate. And that cycle is fine when population numbers are low and there are no political boundaries, people can move around. Obviously, today in a highly modernized world, that system breaks down. Okay, there's more to the construction of miombo than I've said so far. And there's another driver here, and this one I think is it's an interesting one to consider, because it's part of the biogeography of miombo woodland, and it's elephants. Elephants keep the canopy from closing. So what I've told you about this open grass layer is really partly formed and kept as it is by elephants pushing over mature trees, by debarking mature trees, and in debarking and then consuming the bark, the elephants are effectively enabling or putting those mature trees, at risk of burning and then basically of death. So they play an important role. There are other grasslands in this landscape, as well as the natural grasslands that opened up from the animals. There's this thing, it's called Dambo, again, a local name, but this is an edaphic grassland. This is a permanently waterlogged area. Trees just manage to grow on the margins, as you see here. These grasslands provide drinking water for elephants and other animals, and for humans, particularly during the dry months. And there's something unusual about them. There is a large woody mass, it's called underground trees, within this extreme environment. And I just mention this underground world now, again, in the context that from a human perspective, the miombo woodlands also offers a range of underground storage organs, roots, bulbs, and corms. And all you really need to break into this landscape to get to those geophytes is a sharpened stick. It's one of the simplest tools, and one we find even in chimpanzees living in the miombo woodland. Just breaking the surface and then being able to dig out. Okay. The miombo is, I mean, like the Brazilian cerrado, it is a center endemism of a center of unique species, plants, animals, fungi. And on this image here, we have the world's largest mushroom, Termitomyces titanicus, great name. And the genus here, Termitomyces, is a reflection that these mushrooms thrive on termite mounds, a termitaria. The termites, in digesting the soil, have created little pockets of higher nutrition than the rest of the landscape. And there are at least a dozen different types of edible mushrooms here. This one gets up to 3 feet across, a meter. It's really tasty. And I'm just to recommend, if you ever have a chance to fry it in the beer batter, it's great. I've seen some suggestions online that you could use the mushroom as a pizza base. I don't think the texture would be right, but anyway, just throwing those options out there. Coming to the biogeography, and particularly the large mammals that would have been of importance to hunters and gatherers, and also for farming communities who are hunters as well. We'll start with grazers. And by the way, these pictures all come from my field work. These are Cape buffalo. On a large mass like this, they're no problem. But when there's a male on its own, be careful. You're at risk. The the browsers. We've already met the elephants, but we have distinctive form of giraffe here. This is another endemic, in this case, a subspecies. A range of antelopes, beautiful impala here, but where you have such tasty creatures, you also have the range of charismatic predators. They're all there in the miombo. And in fact, the miombo is the most diverse region in terms of fauna, large fauna in southern Africa. But the densities are low, and that's probably down to the poor nutrition of the grasses. A mix of animals, browsers and grazers, it reflects the mix of grasses to woodland. Okay, so that's biogeography, ecology. Let's start to look at the paleoecology. What do we know about the development of miombo over time, but also the human use of this landscape with all those resources I've just outlined? The diagram here shows you 6 million years of climate change. So 6 here, present. And what you are seeing in these movements between basically these fluctuations up and down, these are individual glacial cycles. So take the concept of an ice age and put it to one side, park it, leave it. There are hundreds of ice ages over time. And if you look at temperature on the left-hand axis here, you can see for a period from 6 million to 3 million years ago, this was a relatively warm part of time, a part of time when Africa was covered in forests, plenty of apes, monkeys, and also very early human ancestors. But from about here, climate starts to change, becomes progressively cooler, and the amplitude of glacial cycles increases. From about 3 million years ago, you can see that at the time of the first stone tools, this may be just simple correlation, but at the moment, possibly causation of a changing of the expanse of forest and the opening of grasslands, leading to the development of stone tools. By about 800,000 years ago, look at how dramatic the changes in the amplitude of the glacial cycles are, and particularly down here. They're getting extremely cold and warm. But what's really important in terms of human adaptation, but also for the forest, that not just the amplitude, but the duration of these time periods has moved from about 41,000 years to 100,000 years. These glacial cycles rewrite the distribution of plants and animals and the availability of surface water on landscapes in Africa and on other continents. And it's in this context here that I'm going to introduce the earliest evidence we have of the use of wood for making structures. And to put that into some kind of evolutionary context, this is the earliest evidence we have for Homo sapiens. So, looking at the antiquity, the paleoecology of Miombo, this is the work of Bonneville, and don't need to pay too much attention to the names here. There won't be a quiz at the end, but just get a sense of the duration or the longevity of Miombo. This is 23 million years ago. So MA is million. So 23 to 5.3 million years ago. Miombo was found all the way up here in Ethiopia. This is where it's found today. This is the remaining area of Miombo, but the expanse was vast. Up the East African Rift Valley. 3 million years ago to 2 million, there was a remnant here in Ethiopia, and then Miombo begins to contract with the shift of the rainfall zone, the intertropical convergence zone further south. And by about 600,000 years ago, Miombo is down here in South Central Africa, as we will see now from Lake Malawi. Lake Malawi, but we're back into the contemporary Miombo zone. This is Lake Malawi. It's one of the deepest African lakes, but it provides a good pollen record. So here's the lake, and in the kind of bright orange either side of it, you have wet Miombo, and in the kind of mustard yellow, we have dry Miombo, and then there are other forms of forest here, Afro-montane. I'm interested in this particular pollen zone. So these are forest phases produced by Sarah Ivory and her colleagues analyzing the Malawi core. There are 9 of them over the last 800,000 years. This one, zone 3, F3, is the one I'm really interested in because of its longevity. So this is 470,000 years ago, 270,000 years ago. It's an almost unbroken period of stability in terms of forest availability. So on the diagram that's coming up, you will see here forest zone labeled with F, semi-arid with S, and here's zone F3, and then you track across here, and so this kind of peachy color. This is Miombo, and you can see it's very happy Miombo. It's abundant at this time, and it lasts throughout this time. There are other forests here, but that is the point at which we have unusual stability in this part of Africa, when other parts of Africa are actually going through more rapid change. The yellow bands here are semi-dry phases, and just about here, I might as well mention this, 80,000 years ago, there's evidence of increased fire and decreasing diversity of Miombo to the point where it's very much similar to it as it is now in terms of its tree diversity. Down here in F3, much more diverse habitat. Okay, let's now move to the archaeological record. And this takes us to my work over the last 30 years. 2 sites, one called Mumbwa Caves, and it is, the name is correct. There are more than one opening into it, so it's called caves. And Mumbwa's down here on the border between dry Miombo and wet Miombo. And Kalamba Falls is the place of my more recent work. Won't spend much time on Mumbwa. This is something I did in 1990s, just after the first field work I did after my PhD. And what we developed through the deep excavations here, almost 8 meters deep, 24, 25 feet, we developed a record of more than 200,000 years of vegetation change based on phytoliths and also on microfauna and fauna. But we also have an archaeological record here. But what's interesting down here with Mumbwa people don't stay there forever. And there's a reason why, because Mumbwa, to its west out here, is the Kalahari Basin. And we know that over time, the Kalahari today, which is semi-arid, became proper desert arid, and then spread as far north as the equator. And it had an impact on Miombo. It disrupted it in its western areas. So we have this period of abandonment of the cave, and then people return when it's Miombo. Okay, that was Mumbwa. Let's move to kind of the star side of Colombo Falls in its wide, bigger African context. This is the southern end of Lake Tanganyika. There's the Colombo River. And Colombo Falls, on the right here, is the second highest falls in Africa. But that's not particularly relevant here. But behind the falls are deep waterlogged deposits, and they preserve bone. Sorry, they don't preserve bone, they preserve wood and other plant remains. There is no bone, sadly, at Colombo Falls. So this is the lip of the falls, looking upstream with a site behind. And if you stand in the lip of the falls here on the right, you're looking downstream. You're looking down into the Colombo Gorge, Lake Tanganyika, and just a little kind of a moment of a shared experience here. 2006, we were working at Colombo Falls, and where you're seeing the sunset is where we would do our bathing in the evenings. And on retrospect, this was not a smart thing to do, but it was the only water around. It wasn't smart because when you step in there, the stones are covered with algae. They're slippery. There's a current, and there's nothing to separate you and a drop of 230 meters. Fortunately, the only thing we lost, a couple bars of soap. Everybody survived. And just want to demonstrate with this image here on the left is that the preservation of waterlogged deposits at Colombo Falls is remarkable. There's nowhere else in Africa do we find it, something this old that has been permanently wet for 500,000 years. And if the picture is up, I hope it is, there is a leaf. Here it is. There is a leaf embedded in clay. There's a stem of the leaf. There's another leaf underneath it. And this is the first time this leaf has been exposed to oxygen for 324,000 years. And within minutes of exposing it to oxygen and daylight, the leaf curls up, breaks, and gone. We put a core through this, and we've saved a core. We have this material at the University of Liverpool, arranging for its analysis. But it's an example of the kind of conditions which led to the preservation of wood, creating an anoxic environment where degradation from oxygen was basically stopped. Okay. I wasn't the first person to work at Colombo Falls, and I just wanted to thank Desmond Clark. Here he is on the left. He discovered the site in 1953 and undertook large-scale excavations in the 50s and in the 1960s. And if you have this picture has come up here, you can see the large opening of one particular site, site B. And in site B, people are gathered here. They're working around tree trunk. They're working around areas of organic material. Clark B. Site B, there are stone tools from the early Stone Age. There's possible evidence for fire. There's wood, and you can see on the right, big pieces are tree trunk, the smaller pieces, and the piece in the middle, which overlaps another piece of wood. There are smaller pieces of wood which look like wooden tools, but fortunately, or unfortunately, there's a problem with it. Not only is this material undated in Clark's day, he only had radiocarbon dating, but the wood itself had been abraded, had been rubbed by the movement of the river, so the direct evidence of human modification was basically removed. he could not be absolutely certain that these were humanly made artifacts. What he did find was a long pollen sequence. And there are 3 pollen zones here, and they all have miombo. And this work was published in 2001. Okay. That was there in 2006. I went back in 2019, not expecting to find wood. In fact, this was, what they call it, serendipity. The site where we were going to excavate, a team of students and colleagues from Zambia, that site had been destroyed by the river. Fortunately, it had a fallback, and that I just got anybody planning field work, particularly archaeological field work, far away from in a remote area, make sure you have fallback plans because things will not go as expected. But this moment of serendipity went better than expected. So we dropped down the kind of 9 meters here into this riverbank, which I could see, and you can see now on Google Earth. Don't go now, but just, after the talk, you could have a look. You'll see this white band. And down in here, it's a little bit of dark, and that's play. A couple people from the team. We're just beginning. This is upstream from Clark Site B, and this is called Site BLB. Okay. Let's just look at BLB. I don't want to tell you about the stratigraphy and the dating. I just want you to get a sense initially of how small our excavation was, but compared with Clark's large-scale work. We were only there for basically 4 weeks. Not all of that time was excavation. There are 2 areas here I want you to look at, Unit 3 and Unit 5. These are the oldest material, 500,000 years ago. Unit 2 is about 400,000 years ago. Unit 4, about 324,000 years old. Each one of these produced artifacts of wood, and we had no expectation that was going to happen. Okay. Let me just show you briefly one of the 500,000-year-old deposits. We're now below river level. And I'm squatting here in front of a tree, and then the tree is sitting on an organic patch, and in that organic patch, there are seeds as well as wooden objects. And let me just share one of 2 finds that came from this patch. This is a pointed shaped piece of wood, and on the right here you can see maybe some of the scraping that has created a point. The dark here is where the wood had been split and splintered, and at the top here is basically a percussion zone. This was a wood that was used in a really heavy-duty way. We think it might have been used as a wedge for splitting open, perhaps other wood. And we know the wood. It's Pigalia africana. We know this from scanning electron microscopy of the wooden. The cellular structure of the wood, and this work was done at the British Museum. The other side, at 500,000 years ago, this is the star piece. This is the interlocking logs. Student excavating here. This is one log across the top with a notch in it. It's overlying this log here with a notch in it. By the way, we're wearing gloves, and we're excavating not with trowels, but with plastic knives and spoons, so that we don't damage the wood underneath. And I'm going to explain to you in a second here why I call this a structure, but let me just give you a generic definition of structure. And that's a combination of 2 or more mutually connected and interdependent parts. And another version of the definition from the shorter Oxford English Dictionary is a framework of assembled material parts. And that is what you're about to see. The excavation still underway. We have this image of the drawing here, the plan view of the underlying log, the overlying piece, and then you can see the excavation underway, and just notches there. And let's just look more at the notch. On the left, we have the lit underside of the notch. You can just kind of get a sense that the shoulder on each side, and then a deep groove in the middle. And on the right, you can see up close, each of these is a mark from a stone tool, a scraper, and that's part of the kind of blizzard of information we now have since this was published of intensive shaping on the interior and in the top of the wood. Yeah. that's set. Okay. Um, let's try to think about this notch for a moment. Scandinavian saddle notch is shown on the right. This is basically, this is how you make a log cabin. And I don't know if anybody's ever used, as a child, used Lincoln logs. Well, this is what I was thinking. I was thinking Lincoln log when I first saw and thought about what I was seeing on the excavation. Now, when I talk about Lincoln logs, and we can look at this later, but it's something nobody here in this country knows about. But I'd like to think maybe older generation Americans know about Lincoln logs. Well, you get the idea. The notch stops sideways movement. It locks in one piece of wood into the next. But whereas a log cabin today is made with notch locking into notch, here we just have one notch. And the clever folks 500,000 years ago solved the problem of the movement of the wood by shaping the underlying log here. You can see in red with the arrow, that part of the wood has been dropped down by being deliberately shaped, and it passes through the center notch. That overlying piece of wood, then, if it did move, it would hit that shoulder and not go any further down. And the two white marks at the back, but the excavation is not finished here, but they show you the flaring of the underlying log. It's been flattened like a duckbill, and it's broader than the opening of the notch on that side. It locks it in. So they've papered this, flared it. They have created a stable format, a stable surface. Maybe it had been supported like this with the underlying log in the middle. I don't know. But we do know that this kind of folk engineering created a flat surface at the top, and they engineered what I would call combinatorial technology, which is a conceptually new approach to tool making. Until this point, as far as we know, tools were made to be held directly in the hand. So a stone tool, one stone tool in the hand, a bone tool in the hand. When you start combining things, you emphasize the material properties of the material. In this case of the structure, they are using wood in an almost structural way and an almost kind of sculptural way. They are not strained as they are with stone by size and by the internal dynamics of stone. Wood has offered a new way of expressing their repertoire of technology. And that's why this is the beginning of a conceptually new approach to tool making. We use this combinatorial technology today. Well, with a toothbrush has a handle, and early stone tools would have been put onto a handle. Okay. Who were the makers? We can speculate that they were this species, Homo heidelbergensis, which existed in Africa 700,000 to 300,000 years ago. And there's another name that's being suggested to make it a bit more specifically African. It's Homo bodoensis. And we have a cranium, beautifully preserved cranium from Zambia, and directly dated to 300,000 years ago. So that ties in towards the end of the Kalambo Fall sequence. Ties into the period just before the evolution of us, Homo sapiens. And there is this reconstruction of heidelbergensis, and particularly this skull, by the Kenneth brothers. I like their reconstructions because they humanize our ancestors. If you look at that skull and you think, oh my goodness, look at those brow ridges, then you look at the reconstruction. Yeah, that's somebody we'd recognize. Okay. Do you remember the Dambo? I said there are lots of underground storage organs. All you need is a stick to break the ground. Well, here's a stick. This is the oldest evidence for a digging stick known on the planet 400,000 years ago, and it comes from Kalambo Falls. Site BLB2. And I just want to tell you about the wood, Kigelia africana. It's the same wood used for the wedge. And today, when it flowers, beautiful red flowers, eaten by giraffe, the flowers that aren't eaten are turned into this fruit. And the fruit is eaten by elephants. And the fruit it also has medicinal value for us as humans. It's colloquially known as the sausage tree. It's found in the miombo woodlands. It can handle the long dry season. One more piece of wood I want to just mention. This is on the right, a plank of wood from the center part of a tree. It's flattened by the overlying weight of the deposit. But at the very top and at the very bottom of this piece, you may be able to make out these cuts. These are chop marks made by stone tools, possibly held in a handle. Because this to get this out of a tree is a lot of work. This is about 324,000 years ago. The artisans in wood, I'll just sort of show you here an exploded diagram of what kind of knowledge they showed of the anatomy of trees, of wood. We have the center here of the tree trunk for the upper part of the structure. This is the big piece I just showed you now. It's flattened, but I think this might have been used as a work surface, kind of a, let's call it a wood age Black and Decker surface. Here's the wedge, upper part of the tree, branches off to the side with the digging stick, and the other piece is here. Everything we know about wood use in the archaeological record from the Stone Age, not just in Africa, but in the European and the Chinese record, is to do with branches. At Kalambo Falls, they are using the whole tree. Fantastic. What is the tree used to make the structure? It's called Combretum zera, and I thought, given this audience, you need to see what it looks like. It's today used traditionally as a timber, 15-meter tall, maximum 38 centimeters wide. That's not a big tree. It can tolerate heavy metal soils, and around Kalambo, there's a lot of iron in the soil. But as I started to understand from Combretum zera, I also realized it has published work, has medicinal leaves, medicinal roots. They're anti-inflammatory. They're being investigated today for treatment of cancer. The roots are also good for making baskets and nets. Now, would it be a stretch to say 500,000 years ago, Heidelbergensis knew about the medicinal properties, could possibly make nets? I don't think that is an issue. And I'd say that because we know that chimpanzees self-medicate. They understand the properties of leaves and roots and bark. I don't know why deny that to a 500,000-year-old human ancestor with a brain our size? Okay. So finally, just from my perspective, what does that discovery at Kalambo do? It challenges our perception, particularly my perception as a stone tool specialist, of Stone Age people's capacity for working organic material. They could work trees, whether they brought them down or got them when they were still green somehow. They had to work them in the green because without stone tools, without iron tools, it's really difficult to work these as dry tools. And they were making wooden tools that were not just about subsistence. Okay, the digging stick is, but the big things weren't. They lived in a stable landscape, the F3 from Lake Malawi. And I think they took time to not just solve problems because they had to by necessity, because they had time to do so, to make things better. They didn't have to move like you imagine hunter-gatherers would, in this case on the left here from the Kalahari. And I put this into the publication, this is an early example of a built environment, people modifying their surroundings for their own need. And finally, for me, and perhaps this is something new for you, the concept of making tools from multiple parts predates Homo sapiens and found in the miombo woodlands, and it was based in wood, as far as we know first. Okay. And briefly, how do we as archaeologists reconstruct the past? Archaeology is a historical science. We base our interpretations on the probability, balance of probabilities. Now, I won't spend much time, but first thing we have to do is make sure we're not being fooled by natural processes that are mimicking human processes. And that's why we involve geologists and geomorphologists. We also do a lot of experimental archaeology, replicating using original stone materials, using miombo woodlands. We see the marks that are left on the stone tools, and we use them to interpret. But we also have, in the case of Zambia and other parts of this area, people who are still using wood and working wood with hand tools. So we have ethnographic observations, such as these tools on the right, which are used for making bark. And I know I'm over time, but just briefly, this is another project I've been running alongside. It's just come to an end, called The Last of the Bemba Bark Cloth Makers of Northern Zambia. It's the Endangered Material Knowledge Program supported by the British Museum and funded by the Arcadia Foundation. And this was an opportunity for a colleague at the Moto Museum in Zambia, I was working with them to record the material culture, but also the intangible knowledge associated with the making of bark cloth. And in watching the bark cloth being made, I also saw the process of the chopping of trees and the kinds of tools that were used, axes and adzes and that sort of thing. What I had no expectation of was this intangible belief, not just the rituals, but also the interaction between tool makers and the world in which they live. This is the late John Coper. He's one of the 3 remaining bark cloth makers. Now there's just 2. But he is making bark cloth here. Here's his workbench, his wooden tools, and he uses iron tools, axes and adzes, and he sings a song. And I understand that the sound won't come through for you, but I'll just describe when I asked for translation of what was going on. I was told that he was thanking the tree for the bark, for sacrificing the bark. He was thanking the tree for the wood, in which the bark was the basis of what he was making there. He also started to complain to the tree that it was so hard that it dented his iron axe blade, and not to do that again. Anyway, I had no idea there was that relationship, and this landscape was alive in ways that we, as like our Western scientists, probably not aware of. Certainly not as archaeologists. So we're going to end just the future challenges. 2 of them: deforestation and climate change. Deforestation is surprisingly the result not of farming, but of urbanization. This is recent work by Sedano et al., but more than 75% of urban populations in Zambia and other areas across Miombo use charcoal for cooking. And the making of charcoal involves the vast clearance and basically cooking down of the wood. It's not the farmers. It's those people drawn to the potential of a better life in the cities. Yeah, how do we deal with this? And it's something I think we can talk about. And I realize I'm well over time. The other challenge is climate change. And research done by Jinga and Palagai, looking ahead to 2070. So not too far ahead, but dry miombo will be spreading as global warming continues. What I don't know, and I haven't seen explained, what will happen if things do get drier, and rainfall falls below that 600 millimeter threshold for miombo. Will we see a further decline? I don't know. I suspect so. Let me just end by saying,
wrap it up, Larry.
For 500,000 years, people have been using miombo. It supplied food, shelter, medicine, and they're still using miombo. It's resilient. And if we can deal with deforestation, it will come back. Thank you for your patience.
And thank you, Larry, for that really fascinating and rich talk. Amazing, just amazing, even just to think about holding a leaf that's over 300,000 years old moments before it disintegrates, and the tools. Right. Anyways, wonderful talk. Thank you so much. We have questions that are starting to come in, and apologies in advance if we can't get to your question, but we'll try to take a few. One participant asks, you gave a wonderful description of Brachystegia and its pods opening up. Are all the legumes adapted in this manner? With fire and elephants and grazing, how do these woodlands successfully regenerate?
As far as I'm aware of, these 3 genera have the pods. How did they regenerate? I think if you're underneath one of these at the time of the year as it's starting to break open and spread, the timing is delayed It's not happening all at once. So they may be grazed when they come to the ground, the seeds themselves, but they're passing through the elephant, or there's a local squirrel that eats these things as well. But by delaying the dispersal, I think that gives the chance for these seeds to take root, basically.
Thank you. We have another question, and this question asks, could you speak to more recent use by old civilizations in Zambia and Malawi? When did the practice of arable cultivation and the purposeful cultivation of trees start within this region? Over 1,000 years ago? Question mark.
Okay, that is a good question. I thought this might come up. The Chitamine system that I'm talking about is contemporary and historical knowledge. I'm not a specialist on the earlier what are so-called Iron Age periods. I mean, we're stuck with these terrible labels like Stone Age and Iron Age. I don't know if they are using that same system. It's an assumption.
Thank you. We have another question. What would the miombo woodland have looked like 300 to 700,000 years ago? Could you summarize the nature of the landscape and its use by humans, fire, land use transition?
I think the landscape probably looked closer to what you see here with the cover image with this kind of vast expanse with some open grassland and kind of the areas around the low-lying downbows. Certainly, you'd have had the elephants through here would have opened this area more than it is now. There are no elephants in this area. To me, a landscape without elephants is a relatively modern landscape in the last 100 years. Something else what I didn't talk about was the widespread distribution of honey. This landscape is a sweet place. And that skull I showed you of Homo heidelbergensis has the worst cavities you can imagine. And one of the suggestions is that they love the honey. I think, okay, this is slightly unscientific. I think this was probably a pretty happy place for hunter-gatherers. Everything is pretty much there. The main stress is the availability of surface water in the winter months. There are major river systems that come off the escarpment here. The Zambezi, for example, the Congo on the other side. You just simply move to these areas. That becomes less easy to do when you've invested in farming and into maintaining a particular place in the landscape.
We have I think a clarification question from Michael, who wants to know, doesn't charcoal cutting allow for resprouting and regeneration, hence not deforestation?
I had seen both the farming area where the landscape's been opened up and basically a kind of garden, but the area around the charcoal burning ovens, which are big, you will see that basically the breeding and a lot of wood over a large area. There are stumps still left, and I think that's a kind of I try to hang on to that as the future resilience of these landscapes. Again, this is anecdotal, but over the 30 years I've been coming to Zambia, and I arrive every time to the capital city, Lusaka. And 30 years ago, you would drive for about 30 miles out, and then you get back to the mature trees. But up until that point, everything's clear. Now, it takes hours, more than almost several hundred miles before I recognize that sort of mature landscape with the mature trees because of the extent, the sort of continuous spread of clearance. Yeah, I think it will regrow, but yeah, in time, but there's kind of inevitable expansion unless something as an alternative is offered, something some solar power, geothermal, to people who have very little money. 30 years ago, when I was working in Zambia, it was one of the 10 poorest countries on the planet. Now, medium income. But for most people, flocking to the cities, they don't have the cash. There isn't the infrastructure. But I don't want to go on about that much further than that. But because I think I'm getting away from the question about charcoal burning. It's just the sheer quantity of it is massive.
Can you speak a little bit? You mentioned at the end that you saw the development of these implements in a stable landscape. Can you talk a bit more about what the significance of that is?
Significance lies in our assumptions that hunter-gatherers are traditionally highly mobile. They will pick up and they'll move and sort of eat their way through a particular landscape, hunt their way through, or go with seas in terms of the water. And they make very few tools. They carry a minimal amount of materials they need, and basically the technology is in the mind. And then when you arrive to the next place, you then cut the branches down and you make your digging stick or whatever it is. What's different here, we've never seen, and we don't see in the archaeological record, that kind of investment in wood until about 11 to 12,000 years ago in the European record. For 500,000 years ago, people are working large trees, and they are shaping them into things that are not portable or not easily portable. I'm not saying they stayed there forever. I'm just saying they may have stayed there longer than we would expect foragers in say, today in the Kalahari. They didn't have to go. That basin, that river valley would have had everything you need. The water was there, plants are there, the animals are there, but also at Colombo Falls, and I haven't mentioned this, not very far away, there are sources of stone for making those big, beautiful stone tools. Everything is there. And I'd like to assume the medicinal component's there as well. If I go back, I would love to excavate a much larger area, cover many more wooden tools, and then we can start to say, are they selecting certain tools for certain properties? Has that feeling already, but the sample size is way too small to be statistically relevant. So that's something I would, kind of on my bucket list. Bucket made of wood.
Great. Well, that is a very nice place to end. So let me thank you again, Larry, so much. We appreciate you taking the time to speak with us and sharing your work with all of us.
And I'm sorry to everybody who had questions. I'm just looking now, and I got carried away. And I took way too long. I think it's just because I just enamored of this woodland.
Not at all. I think it was fantastic for us to hear about your work. So we really appreciate it. And sorry to the people whose questions we did not get to, but it happens in every session. So just a quick reminder, the recordings of today's session will be available within several days on the Yale Forest Forum website. The slight delay allows us time to accurately caption each session, making them more accessible to everyone. Slides will also be made available and, when possible, referenced with documents and readings, and they're going to be linked on the Forest Forum website. So please check back. And we hope that you continue to join us on Thursdays from 12 to 1 p.m. Eastern Time through the beginning of April. As we noted at the top of the session, we will be off next week for Yale's spring break, and we'll be returning March 20th for a conversation with Bill Tripp, again, 12 p.m. Eastern Time. Bill is the Director of Natural Resources and Environmental Policy of the Karuk Tribe Department of Natural Resources, and he is going to be talking to me about Karuk forest and fire management. So please join us for that. One quick note about Bill's webinar and the time is that in the United States, we will be moving to daylight savings time this weekend. So for those of you elsewhere who are not moving to daylight savings time, please be sure to confirm the time of our webinar for March 20th.